All right, I'm back. We're on page 316, and we're just going to do a bunch of problems. So let's see what we got. Classify the critical points of f of x equals x cubed minus 27x minus 20 using the first derivative test by hand. Okay. Use your calculator to confirm in two ways, by graphing f of x, also by finding the critical points and testing them. So let's do it. So first, use the first derivative test. I'm going to need the first derivative. So let's find that. So f prime, oh god, f prime of x is 3x squared minus 27, and that's it. So this you can write as 3 and then x squared minus 9, and then that you probably recognize as 3, x plus 3, x minus 3. So this is a pretty straightforward example. Let's do a sign chart. Sign charts are not enough. So you do the sign chart. The sign chart tells you where the derivative is positive, where it's negative, but then you got to like keep going. Also, I always forget to write down the critical points because you can just like jump to them. So x equals, let's say, plus or minus 3. All right. So usually I wouldn't do that. I was just cramming it in because I forgot to do it. So negative 3 and 3. I look at f prime, it's quadratic that opens up. I know a quadratic that opens up is going to go positive, then negative, then positive. If you're not sure, test the region. Plug in negative a billion, and then plug in a billion, and maybe plug in 0, and you will see that you're going to get the same values or the same signs. We don't really care about the value. We just care, is it positive or is it negative? All right, so I see. I don't really have a convention for increasing and decreasing, but increasing. So f of x is increasing because f prime is positive, and then decreasing because f prime is negative. So let's see, use first. Okay, so I'm going to say that f of x has a relative maximum at x equals negative 3. So let me say that. F of x has a relative maximum at x equals negative 3. And why is that? Well, that's because f prime changes from positive to negative there. So because f prime changes positive to negative at x equals negative 3. And then f of x has a relative minimum at x equals 3 because f prime changes negative to positive there. So let's write that. F of x has relative minimum, minimum at x equals 3 because f prime changes from, so relative minimum, so it's got to be negative. Sometimes what I'll do is I make my sign chart, I look at my sign chart, I decide what's happening. Then I go over and I write my answer, and I write my answer based on what should happen. Then I'll go back and look at the sign chart and see if it like satisfies that. So like here, relative minimum. If I'm saying there's a relative minimum, then f prime must change from negative to positive there. Okay, and then I'll go back and look and say, oh yeah, it does change negative to positive. It's like I'm double checking all my work as I do my work, which I think is a good thing to do. You should like always be checking, All right, so we're supposed to graph this thing, and then we're supposed to also find, all right, let's switch to a calculator page. Enough of this talk, let's see. So here we go. I'm gonna start a new document, I guess, because it's like new page, whatever. So f of x is x cubed minus 27x minus 20. Okay. Let's graph f of x. So I'm going to graph f of x. When I graph f of x, I'm looking for there to be a maximum at negative 3 and a minimum at positive 3. And if we change the window, so let's just zoom out a bunch and then we'll box around it. Out, 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 out. Who is that? Lady Macbeth? Out, damn spot or something. It's like blood probably from some, I don't know. Shakespeare's messed up. I was like, so I mean to go back and read Shakespeare. Like I missed that. I missed when I was like in classes where I had to read Shakespeare. But like reading them is just not the same as like having someone analyze it along with you or for you or whatever. So like, you're kind of missing stuff, Maximum, let's see, here to here. Yes, maximum at negative 3. Will there be a minimum at positive 3? there definitely will be, because we did not mess this problem up. And there we go. All right. So we killed it on that. So I also could have graphed derivative f of x, and I can see the derivative going from positive to negative at -3 and going from negative to positive at +3. So that further confirms what I had. I also here could have done, so menu 3, so I want to solve the derivative. So this is a more of a cast type of thing, equals 0 for x. Okay, I have that. Now, how do I do a sign chart just on the calculator page? Well, if I go up and grab the derivative, I know that the only places it changes sign are -3 and 3. So if I just test like x equals -4, I get a positive. If I test x equals 0, I get a negative. So it must be the case that the derivative is changing from positive to negative at -3. So the function f of x should have a maximum there. And then I could test, I don't know, 10 or something, right? So the derivative changes from negative to positive at x equals 3, because I know the only places it changes are -3 and 3. So that's how I'm like effectively testing regions here, just using the graph page, the calculator page rather. I don't ever really do this, but I could do it. Another thing you can do is you can just like have the calculator solve, like, when is the derivative less than 0? The derivative is less than 0 between -3 and 3. So that's where your minuses go on your sign chart. Greater than 0 when x is less than -3, and when x is greater than 3. So you can fill in your pluses on your sign chart based on that. You have a lot of options. If you have the calculator with you, you have, like, the sky's the limit, really. Like, whatever you can think of to do, the calculator will help facilitate for you. All right, let's see. Blah, blah, blah. All right, let's try this next one. So graph the derivative f prime of x of f of x. So this is the original function, not the derivative. So let's be clear on that. So this is the original function, and this is the graph of f. So we're given the graph of f. This is f. So f of x. All right, so why would you be given the graph of f? One of the reasons is this is a really annoying problem to enter on your calculator, and the person who wrote the problem is making sure that you can, like, tell if you entered it correctly. So that's what I'm going to do. I'm going to switch over to the calculator, because that's what we're supposed to do. So switch to the calculator. New problem, definitely, doc41. And I'll add the calculator page. So f of x is, so cosine of x squared. So I'm going to do cosine of x and then just put squared. If you're not sure if that's right, put in this parenthesis, which is optional. And when I press enter, I think it's going to get rid of it, but plus sine of x. But if you're not sure, you know, oh, it didn't get rid of it. Okay. But like, if I ask you what f of x is, no, it doesn't it keeps it. Okay. What if I hadn't put it in? It's really annoying to do that, actually. So let's see, cosine of x squared plus sine of x. Let's press enter. It puts it in. It's optional, but the calculator really wants it there. All right, that's f of x. So let's check and see if we entered it correctly by comparing it to the graph that we were given, right? So we were given a graph of f of x. Let's change our window so it looks exactly-ish the same as what we're given in the notes. So in the notes, it looks like -0.5 to, like, honestly, it's probably like 2 pi. And then negative, let's say 1.2 to 1.5, I guess, seems to be. That's a weird range, but compare this to what's in the notes and you can see it's exactly the same. Okay, so that's good, because that means it's worth doing the rest of this. So I'm going to insert another calculator page, and I'm going to find the derivative of that thing. So why am I doing that here? Use the graph of the derivative. I'm not going to. All right, I'm going to put in a graph page. All right, derivative. You should use the template, though. Remember, templates, pick the one that's for the first derivative. I'm kind of stuck on that because I've been finding a lot of derivatives lately. F of x, and then x is the variable. So you can see if I hit tab and go back up, it switched it over to the template. So like, I'm typing these things. It's going to, if a template exists, it will change it to the template after you press enter. All right, we got this. I think that I should change my window again. So this is great. I should have just used the previous graph page, but I didn't. 2 pi negative 1.2, 1.5. I feel like that's what we said. Okay, so this isn't, it's enough, but we can't see the whole thing, so I'm going to change my window again because, like, yeah, I'm kind of like a window snob. I like to be able to see, like, everything that I should see. Negative 2, perfect-ish. Okay, so find and classify the critical points. So let me add in 0 just so I can find the critical points, right? There are no places the derivative fails to exist. So the critical points are going to be when the derivative is equal to 0. So I'm going to do menu 814. You can use, so the calculator can find zeros, but it'll do it one at a time. Whereas menu 814 is the intersections. If you intersect two functions, it finds all the intersections that are on the screen at the time, at the same time. And I think that's like way faster. So these, some of these look like exact value. Well, that looks like pi over 2 to me. And I'm going to guess they're all like pi-ish things. But anyway, what can we say? All right. So at 0.524, let's say, the derivative changes from positive to negative. So that means that the function has a relative maximum at 0.524 because the derivative is changing from positive to negative. At 1.57, the derivative is changing negative to positive. I should say 1.571, I guess, because of correct rounding to 3 places. Derivative goes negative to positive. Function will have a relative minimum. 2.618, the derivative is changing from positive here to negative here, which means that the function will have a relative maximum. And then at 4.713, no, 4.7, yeah, 4.712, I'm actually not that good at rounding, it turns out. It's more that I'm not good at reading decimals. I know how to round. It's just like, 3 decimals? Like, what is the number 3? So 4.17, no, 4.712. The derivative is going from negative to positive, which means the function has a relative minimum. So what are we going to do? All right, I'm going to switch back to the notes. I'm just going to make a sign chart because I feel like we should. It seems like a good thing to do. So switch back to the notes. I'm going to be looking at my calculator page, though. So like this could go very poorly. Hopefully it doesn't. Okay, so based on the calculator, we're going to sign chart this thing. So get bigger. Okay, f prime. So it'll be a sign chart for f prime. And on the sign chart, I'm going to put 0.524, 1.571, 2.618, 4.712, right? So it's important to realize that you can take a graph of the derivative and turn it into a sign chart. You can also kind of take a sign chart and turn it into the graph, but like not as accurately. So here we go positive, negative, positive, negative, positive. Okay, so the critical points, what am I supposed to do? I'm supposed to find and classify the critical points. All right, so I'm gonna, all right, so the critical points are x equals, or I'm gonna say approximately. Oh, bad approximately. 0.524, 1.571, 2.618, 4.712. All right, now, when you have multiple minimums and multiple maximums, what I like to do is I like to group my explanations. So let me go through the chart, and I don't really need to do this, but it kind of looks nicer in the end if you kind of like take some time and care about things, All right, so where is there a relative maximum? That's where the derivative goes positive to negative. So there's a maximum at here at 0.524, and there's another maximum here. So what I'll do is I'll group my explanations for those. I'm going to say f of x has relative maximum at x approximately equal 0.524 and no comma there, and x is approximately 2.618. Okay, now I have to say why. Well, why would you have a relative maximum? You'd have a relative maximum because the derivative changed from positive to negative. So I'm going to say because, let's say because just f prime. Because f prime of x changes positive to negative at those values. So at those x values, let's say. X values. All right, there we go. Now let's group our justifications for minimums. Where are their minimums? So there's going to be a minimum anywhere the derivative changes from negative to positive. So that's not a highlighter at all. The derivative changes from negative to positive here and here. So let's say f of x has relative minimum at x is approximately, what are these values? 1.571, which I feel like is really pi over 2. And x is approximately, so this is probably 3 pi over 2, but like whatever, it doesn't really matter. 4 point. You would think I would know those, but like they just don't come up enough for it to be worth it. Why are there relative minimums? So because f prime of x changes negative to positive. So it's a lot of writing. People gripe about this, like algebra 1, algebra 2, even most of this course, like you just don't do a lot of writing. You get to this part and it's like write down everything at those x values. And I kind of like, I understand. I don't care, you know, complain all you want. You got to do it, right? So that looks pretty good. I feel like if you have access to a lot of highlighters, like get in the mood, man. Make your notes look nice. All right, I'm gonna do this one because I'm here and I don't think it's long enough to justify another video. And this video is probably long, but not impossibly long. So let's just go for it. F prime is x squared. So 1/3 x cubed is great. Like you see it and you freak out. You're like, fractions. But because of the power rule, it's gonna cancel that 1/3 out. So it's actually like ideal when that's there. Minus 2x minus 3. This is gonna be good. Let's factor that. F prime of x equals x minus 3, x plus 1. So f prime of x equals 0. So you get the sense like critical points are usually when the derivative is 0. It's undefined for a lot of things, but like piecewise functions, absolute value things, like polynomials, it's never going to be undefined. And polynomials are like a really common thing to deal with. Sign chart. We're getting really good at this, I think, right? Same process every time. F prime. Quadratic, it opens up, so I'm gonna do my thing. Pluses, minuses, pluses. All right, so I see positive, positive. I see a negative. All right, so I'm gonna say f of x has a relative maximum at x equals -1 because f prime changes positive to negative, to negative. There. Every once in a while, the stylus just like doesn't pick up. Like you write something and it doesn't show up, and that's usually when I say, oh God. F of x has relative minimum at x equals 3 because f prime changes negative to positive there. Negative to positive there. Okay, so if I wanted to kind of like sketch this, like it doesn't really ask me to, but if I found f of -1, f of 3, the graph would be better. I'm not going to do that because that seems terrible because of that 1/3 there. But I do know that the function is doing something like this. I have no idea like the relative heights of those because I didn't find anything, but I know that this is at -1, f of -1, and I know that this is at 3, f of 3. And there you go. So if you've got it down, you're good to go. Like you can do a lot of problems like this. Keep thinking about like what's going on. Eventually we want to get into the second derivative and what's happening there. But if you are keeping up and taking the notes and thinking deeply about these things and asking yourself questions and answering them, asking others questions and getting answers to them, you're in good shape. So I'll be back in the next video to do more of this stuff. I hope you're finding them helpful, and I'll see you then.